350 utility razor blades, the kind people use to cut paper, cardboard, wallpaper, cheap, disposable, tossed out by the handful. Today they're becoming a blade with a pattern you won't find in any production steel. Powder, pressure, fire. From trash to Damascus. We thread the blades onto a rod, tight, no gaps. On top, a steel die. This isn't a mold. It's a pressure chamber that'll hold everything together during forging. We pack in steel powder. It fills every void between the blades, binds the layers, works like a weld filler under pressure. Tap it down to consolidate. The billet needs to be solid before the first heat. Utility blades are typically the equivalent of 1080, SK5 or 65 Mann. Carbon steel, good response to hardening. The powder, either tool steel or 1095. One rule that doesn't bend. Every component has to be dry and degreased. One drop of oil in that billet is a guaranteed cold shut. We weld around the perimeter of the die. The bead has to be continuous. No oxygen gets in during the heat. Let it in and everything oxidizes. Instead of Damascus, you get a crumbled pile of scale. Drill a vent hole. On the first heat, air and excess pressure need somewhere to go. Skip it, and the die blows out from the inside. Into the forge. Heat slow and even. The billet warms from the walls inward. Rush it and you get a cold center with welds only on the edges. And we run it again. At temperature, pull it out. Under the hydraulic press. Slow, steady pressure, not impact. That's what a powder billet needs. A hammer scatters the powder and breaks the structure. The press pushes it into every gap. Back in the forge, back under the press. The cycle repeats. With every pass, the billet loses its memory of ever being a stack of blades. It becomes one piece of Damascus. Then the power hammer. Now, fast, frequent strikes. Consolidate, draw out, turn a short, thick block into a blade blank. PRO tip. First two passes. Vertical compression only, no drawing. Weld first, then draw. Try to pull an unwelded billet and you'll get a layered mess full of cracks. Billet's cooled. Chisel, hammer. We knock off the outer die, the shell that held the pressure. Underneath, Damascus. First look at the cross-section. If you see a uniform structure with no delamination, the weld worked. If you see voids or cold shut lines, back in the forge, add borax, weld it again. Marker comes out and we trace the blade profile. Angle grinder cuts away everything that doesn't belong. Don't baby the metal. Better to remove the excess now than spend hours on the grinder later. If you're into watching everyday objects get turned into blades, subscribe. There's a lot more metal ahead. Grinder. Flap wheel. Grind the bevels, rough first, then finer. Hold that angle steady along the full length. Stainless-based Damascus from razor blades grinds harder than plain carbon steel. The abrasive loads up faster. Cool it more often. Don't bring the edge to zero. Leave 0.5 mm before hardening. A thin edge will warp or crack in the quench. Stainless Damascus from razor blades needs tighter temperature control during grinding. Overheat the edge and you've locally tempered the steel. Then everyone blames the metal. But it was the hands.